question number 5. Number 4 was a division question. Question number 5, they're going to ask us to take this function and find its range. So we do that by division. We can find the range if we rewrite this as a quotient. You remember how to divide polynomials. There we go. This is number 5. X goes into x squared x times. So x times x is x squared. X times a negative 1 is a negative x. Draw the line, change the signs, add down. These two are 0. Negative 5 plus 1 is negative 4x plus 6. So x times a negative 4 gives me the negative 4x. Negative 4 times negative 1 is plus 5. I'm sorry, 4. Making up my own numbers here. Multiply. There we go. I wrote it down again. Boy, the brain. There we go. Positive 4 to start with. Draw the line. Change the signs. Add down 5. I want that 5 in there so bad, I'm going to make it 2. There we go. Where I'm getting that 5 from? Monkey business. All right, so here's my quotient. Here's my remainder. And so when I write it into my software, they want the quotient in front. They already have the x and minus. You just have to put in the number 4, and then you write your remainder on top of the fraction they give you in the software. So that's where things live. Quotient plus remainder, just like a mixed number, quote unquote. Now, because this value is unknown yet, we cannot use ordinary means to find the range. So we have to use Desmos.com. So if you go there, please, and engage with me, you will feel the creation of the solution. / calculator. Okay. And that's where we're going to get our range numbers. We'll have them in inequalities. And we'll go from there. The directions say round to the decimals to the nearest hundredth. So we're going to round our values to nearest hundredth. So that I'm going to get these values from the graph, and I'm going to put my polynomial, my rational function in with using the quotient form. It was a little easier to type. I'll pop over here. That's this top one here. See, I put in x minus 4 plus 2 over x minus 1, and then I can show you where I get my values. You want to use the one that comes up, and then peaks. Let me go. I'll move this over so you can see it. It peaks here. You want to pick the
value, the y value that's at the top of this curve, and then the y values that at the bottom of the curve. So my first number, my least number, is negative 5.83, and my after number is negative 0.17. So that's what you get to do. And maybe you have the same answer or, question problem I do, but don't just copy. Understand. I just got out of my screen here. Let's come back. I don't know what's going on. It's being a hoot. Okay. Get out of the way. I need negative 5.3. Negative 5.83 and negative 0.17. Okay? So you see, I use the y's, remember? The y's. 7's a little weak. He's standing up.
So the set notation, set of all y, such that, and this stuff just goes in there.
Same values.
Still really hard to read. Okay. And then the interval notation, you put your negative infinity to your decimal. That's the smaller of the two, and you union it with the next decimal to positive infinity. So that's the complication of rational functions. In this case, for number 5, it's because the quotient was a polynomial. Okay. So all I can ask you to do for these kind of problems on an assessment would be able to rewrite it in quotient form. That's all. Because the rest of these, then we're going to use decimals to answer. Okay? All right. I'm going to go to number 6. If you're ready. Off the screen there. It's another division problem. It gave us 4x squared minus 1 in the numerator. This is f of x. And x squared plus x minus 2 in the denominator. That's going to be our divisor. And this is our dividend, is what it's called. I need a space for x to the first power, remember? There's not one, you got to make one, make a placeholder. So you remember it's there and you have all your like terms all organized. So x squared times what is 4x squared? That's a big fat 4. See if my brain's engaged now. There we go. I multiplied each one of these by 4, 4, 4. Then I need to change the signs. So that first term cancels. I get a negative 4x plus 7. So there's the quotient. Here's the remainder. And that's what they're going to have you write as the form of this function. Quotient goes first. But because the remainder is not a constant, you put in that part, you just have to put in your quotient. Remember who goes where. My divisor is already there in this software. Now because the numerator here is not a constant, we have to go ahead and use Desmos. To find our values. And to find the range. So I'm looking for my y values. You enter this polynomial, either the original or the reformed one.
And see what the y's are. Let's move this over a little. There we go. That's this one. If you remember, if you putting in a fraction, you gotta put the parenthesis over the around the numerator so it turns into fraction. I didn't have to do that up here because the 2 was just a number. So, okay, boy, oh boy, that looks like fun. So I have my 4 and my negative 4x plus 7 on top and my x squared plus x minus 2 on the bottom. So I've got to be looking for when does the y stop here. Okay. Right there. Okay. Woo. When does the y start here? Right there. So I think they said in the homework it was a
Round any decimals to the nearest hundredth. So that one is tricky. So my bottom y is less than 0.51. Then my top one, y starts up after 3.49. And so my set notation, set of all that y, such that use the same information and negative infinity. So once you get it, you just repeat it, making sure everything is in order. Okay, that is number 6. So be sure you round correctly. I think I goofed around wrong in my 4th period. I'll have to tell them. Okay, 7 is a bunch of fun. 7's a whole 7, 8, 9, 10, 11, 12 are the the top of the mountain. Okay, so we're going to start with number 7, and just know this is the pattern you're going to follow through the rest of the assignment.
I'm going to put this out here first because see if it goes, because there's things to talk about before we get to the graph.
So I have my original function, x minus 2 over x plus 2. I have to talk about the vertical asymptote. I have to talk about a horizontal asymptote. I have to talk about an x-intercept. Okay, then they have the graph, and I'm going to skip down. Then I have to talk about the domain and the range, where you find that information. Alrighty. So we've done these before. It's just now we get to do them all together and pick the graph.
So the graph would be last. That's what we'll see on Desmos. So vertical asymptote comes from the bottom. X cannot equal -2. So the asymptote is equal to -2. Remember where we get that? That was blue in our story. Okay, horizontal asymptote is what y cannot equal. So it's y equals, and if you remember, we get it from, if I divided numerator by denominator, I get a quotient of 1. And that's where we get the horizontal asymptote. It's the coefficients in the front. If they're the same powers, the coefficients in the front is the horizontal asymptote. I don't know. Got a good color for that one. I don't really. I'm just going to leave that one empty. The x-intercept is what makes the numerator 0, right? So it just has x equals in the homework here. So you only have to put what's going to make the x 0. Okay. I think the holes were yellow, weren't they? Whatever color x-intercepts were. We'll look back. Did we have any on this lesson? I don't have it there. So you can make it any color you want. I'm going to make orange, just so you can tell where it comes from. Okay. And so when you look for the graph, you look for these details. Or, again, put it into Desmos. So the domain comes from, it's everything but the vertical asymptote. So x is less than a -2, or x is greater than a -2. So x cannot equal a -2. And then our interval notation, -infinity to -2, joins with -2, goes past, jumps over to +infinity. So they got us pretty easy so far. And then the range is y is less than the horizontal asymptote, 1. Or y is greater than 1. Y cannot equal 1. And we have the interval notation goes from -infinity to 1, then it jumps over after 1 to +infinity. So you can use Desmos.com, or you can just sketch it out. This is our last one. Yep, I'll go ahead and call this our last one. We'll sketch it out. Vertical asymptote is x equals a -2, so that's here. Okay. Horizontal asymptote, y is 1. I guess I'll make him pink. So right there. There was no flipping, nothing flipped or anything. So the curves are going to be in the first region and the third region. So I'm looking for a -2 here and a 1 here. So I'll show you what they have to offer you. Here they have a -4, so that's out. Here they have a +4, so that's out. Here they have a -2 and a +1. Looking good, but look. Ooh, they're in the wrong quadrants. How could that be? So C has got the right asymptote. Let's see what happened. Maybe I can't say this because of the complicated.
So I jumped to a conclusion, but I couldn't, I shouldn't have, because it's complicated. So that's why this curve went that, and he went there. So there we go. And the asymptotes are wrong. So the asymptotes are going to be, and I didn't use decimals. So moral of the story, use decimals. Asymptotes are going to be right, but the curves moved because of the complicated function. There was a numerator with a variable as well as denominator. So I don't know if you guys want to erase it or just reform it.
But you will not be asked that on the test, just the homework. So let's see. I'm going to put in x, what is it? X minus 2 over x plus 2 in my little delight. X minus 2 over x plus 2. And there they did. They flipped. They did flip on me. So you can see, if you want to, you can put in the x equals 2 as a negative 2 as an asymptote to make sure that's right. Make it a dotted line. Okay, and then the other one was y equals 1. And make that a dotted line. Like the dotties, dotties, dotties. There we go. And voila, there's our story. So that's what you're going to have to do to find the right graphs for 7 through 12.